This is SpaceTime, Series 28, Episode 93, for broadcast on the 4th of August 2025. Coming up on SpaceTime, Australia's first orbital rocket launch in years fails seconds after liftoff. A new study says the evolution of life may well have its origins in outer space. And Boeing's trouble-plagued Starliner spacecraft delayed until at least 2026. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, they say space is hard, and Gilmour Space have just learnt that lesson with their ERIS 1 orbital rocket test launch crashing back to the ground just seconds after liftoff. Following days of delays due to bad weather conditions, launch day dawned fine and sunny, with spectacular clear blue skies, a few fluffy white clouds in the distance, and the Bowen spaceport on tropical North Queensland's Pacific coast looking spectacular. The 23-metre-tall three-stage ERIS rocket appeared to lift off nominally. However, just 2 seconds after launch, one of the ERIS rocket's 4 hybrid Cirrus main engines appeared to fail. The launch vehicle continued to climb on the remaining 3 engines, clearing the tower, but then a second engine also appeared to shut down about 5 seconds later. Now, by this stage, the launch vehicle had reached an altitude of just 50 metres, and the loss of so much thrust caused the rocket to stall and begin pitching over and drifting sideways, although still remaining in the vertical configuration. Although images showed fire still shooting out of the rocket engine nozzles on the 2 failed motors, they no longer had enough chamber pressure to develop thrust, resulting in the vehicle falling back to the ground in a massive cloud of white vapour. The white vapour was the hydrogen peroxide oxidizer, which was used to ignite the solid fuel component of the hybrid engine. An investigation reviewing the flight data is now underway, with special attention focusing on the oxidizer pumps. The good news is no one was injured in the crash, there was no environmental impact, and the launch tower and ground facilities were undamaged. Gilmour Space says the launch vehicle had suffered an extended 18-month delay on the pad, waiting for final government approvals and, of course, the weather. The company says the launch experienced smooth operations throughout the terminal countdown. It says there was a successful auto-sequence at ignition of all 4 first-stage hybrid rocket engines, with 23 seconds of total engine burn time, as well as the 14 seconds of flight. And there was a successful integration of operations between the launch vehicle itself and ground systems. Flight software and GNC performed as expected, there was extensive flight data collected during the test, and a safe execution of launch and range operations. Company CEO Adam Gilmour says mission managers learnt a tremendous amount that will go directly towards improving the next launch vehicle, which is currently still in production. Gilmour says only 6 nations currently launch into orbit on a regular basis, and just a handful are developing sovereign capabilities to join them. He says Test Flight 1 marks several national firsts. It was the first integrated launch of a fully Australian-built orbital-class rocket and the first use of a licensed commercial orbital spaceport in the country. All core systems, including propulsion, avionics, software and infrastructure, were designed and manufactured by Gilmour Space, supported by a team of over 200 staff and 500 Australian suppliers. Gilmour says they'll try again with the ERIS 2 test flight in coming months. The 30-ton ERIS rocket is designed to launch payloads of up to 300 kilograms into low Earth orbit. But for this first test flight, the only payload on board was a jar of Vegemite, a favourite Australian sandwich spread. And images show that it appears to have survived, well, sort of. As well as the 4 hybrid Cirrus main first-stage engines, a single Cirrus hybrid engine is used for the second stage, while a conventional liquid oxygen and kerosene-fueled engine is used on the upper or third stage. Astrophysics Professor Jonty Horner from the University of Southern Queensland described the test as actually being the best first launch he's ever seen. Horner says it's all a key part of how new rockets and spaceflight technologies are developed, and teams learn a lot more from what goes wrong than what goes right.
To be honest, they'll have an incredible wealth of data from this. They will have had cameras everywhere, all the sensor feedback and everything else. And I'd expect them to be able to, even though they're already building that second rocket, to be able to take advantage of what they've learned from this first attempt. And next time should be bigger, better, faster. will probably still not make it to space. I think they'd be overwhelmingly surprised if the next time they test it, they get into orbit. But they'll be able to apply what they've learned from this one, do a better job next time. And it's this progression towards finally having the commercial product that they want that is able to reliably put things into orbit on demand.
Gilmour says that all the avionics, all the core systems, the software, it all performed exactly as it was meant to. So they would have gleaned a ream of information from that launch.
No, absolutely. And I think when one engine fails, your rocket would naturally tip over because it's no longer balanced. But it stayed vertical because the kind of attitude control jets that they've got on there did a really incredible job keeping it upright, essentially. And that, to me, is probably the kind of thing that is really gold in terms of the knowledge that they get for the Gilmours, because they show that all those other systems worked well. Because if you think back to those early footage of them, they always show this in comedic form in cartoons on TV when they're building a rocket. You get those old footage of rocket launch failures from the 50s and 60s. And one of the really common themes is rocket goes up and falls over and crashes. So for this one to go up and something go wrong, but it instead hovers and tacks sideways, that's actually a really good sign that a lot of the systems are working really incredibly well and are very well engineered for me.
Space is hard, and I guess Gilmour Space have found that out, but I guess they also always knew that.
I think if you look at the comments they were making in the run-up to the test, they were saying they'd be delighted if they just got off the ground. And for me, I look back to being a kid in the 80s and 90s getting really obsessed about astronomy and space. And at that time, you had all this footage from the dawn of the space age of all of the many and various ways that both the Soviets and the Americans failed to launch a rocket. And they were always very explosive and very cataclysmic. And we've seen that kind of same model play out with the development of commercial launch capacity over the last decade or so. And every time SpaceX introduces a new rocket, for example, it gets tested to destruction. They have their rapid unscheduled disassemblies going on all the time. And in light of that, I think in my memory, of all the rocket launches I've seen, and I stress I'm not a total mad space expert like some people are, I don't watch every single launch, but this is about the best first launch I've ever seen. It was, for me, a really wonderful success rather than the failure that some grumpy people on social media seem to try and want to paint it as.
The idea of orbital launches from Australian soil isn't really new. We were launching rockets from the Woomera rocket range into orbit in the 1960s and early 70s. These included Australian-built satellites, US and British rockets. In fact, at one stage, Woomera was the second biggest spaceport in the world. Only Cape Canaveral was busier.
That's sadly ancient history. That was before I was even born. Because once that stopped, there's been this enormous long period where we've not really been involved, to be honest. I think this, though, is a slightly different beast in that this is a real attempt to have a commercial program where you've got Australian-built rockets launching from within Australia, so keeping everything in-house. And to me, that's really serving two kind of simultaneous benefits from a commercial point of view. It means that people in Australia who want to build a satellite and get it launched don't have to export that satellite. You don't have to pay somebody in another country to launch from another country, ship your stuff there. So you're not exporting wealth in that sense. At the same time, it also means that people overseas will be able to look at Australia as providing a launch option for them. And so commercially, we may well have packages being launched to space that are built outside Australia. And so we're instead importing wealth. We're importing money as this commercial thing. I think that's a niche that the Gilmours have identified. They're looking at launching satellites up into low Earth orbit, where there are more people who have satellites to launch than there are rockets available to launch them at the minute. There's a real kind of bottleneck there. So that's really promising from Australia from a commercial point of view. It also gives you that kind of sense of sovereignty, sovereign capacity that you're not reliant on other countries. But to me, I think probably the thing I get most excited about this is simply the kind of inspiration. The idea that young kids in Australia who are excited about space and excited about rockets, historically, if they wanted to become rocket scientists, if they wanted to work with rockets and make their career out of that, they had to go overseas. And we had this brain drain where you had some of the best and brightest having to go to the US or to Europe in order to pursue that dream, in order to pursue that career. Whereas now we're showing that in regional Australia even, people have the opportunity to follow that career, follow that, and make it a pathway that they can stay in Australia and do. So maybe we'll see some of the brain drain reverse. We'll get some people back to Australia who moved away.
I think we've seen the potential future when we look across the Tasman Sea to New Zealand, where Rocket Lab have done brilliant things. They launch, once every 2 or 3 weeks now?
That's an incredible achievement, and it does feel like Australia's playing catch-up. I seem to remember when the Space Agency was established, people were trotting out facts about how many other countries had space agencies before we got one. And I believe we were something like the 83rd. Please correct me if I'm wrong there, but we were somewhere in the 70s or 80s as a country that was finally having a space agency. And other countries have stolen a march on us with this transition from space being purely a government exercise where you were really only looking at a few entities like NASA, European Space Agency, JAXA, the Soviets, Chinese maybe. Suddenly you've got companies springing up all around the world and countries investing in it. New launch facilities all the time. There was a big stir here in Queensland just on Wednesday when we saw clouds from a rocket launch in the evening sky at about 6:30 p.m. And it turned out that was a Chinese rocket that had been launched from one of their commercial space launch facilities, putting up the Chinese equivalent of Starlink, their own communications network, that had launched over Australia. And we saw the first stage separation, the boosters falling away, gave a very distinct show that freaked people out here in southeast Queensland. And that's going to become more common. Everybody around the world is getting involved in this because it's gone from being the few wealthy countries that could afford to do it to being a commercial enterprise where everybody can get in the game and there's money to be made.
That's Professor Jonty Horner from the University of Southern Queensland. And this is SpaceTime. Still to come, a new study says the evolution of life may have its origins in outer space. And the next test flight for Boeing's long-delayed and trouble-plagued Starliner spacecraft now delayed until at least 2026. All that and more still to come on SpaceTime. Astronomers have discovered complex organic molecules, which are precursors to the sugars and amino acids essential for life as we know it, in a distant planet-forming disk. The findings, reported in the Astrophysical Journal Letters, provide more evidence supporting the idea that the evolution of life may well have its origins not here on Earth, but in outer space. Astronomers using ALMA, the Atacama Large Millimetre Submillimetre Array Radio Telescope in Chile, detected signatures for complex organic molecules, including the first tentative detection of ethylene glycol and glycolonitrile in the protoplanetary disk of the outbursting protostar V883 Orionis. These compounds are considered precursors to the building blocks of life. Comparing different cosmic environments reveals that the abundance and complexity of these molecules increase from star-forming regions to fully evolved planetary systems. And that suggests that the seeds of life are assembled in space and are widespread. Astronomers have already discovered complex organic molecules in various locations associated with both planetary and star formation. Complex organic molecules are those with more than 5 atoms, at least one of which is carbon. Many of them are considered the building blocks of life, such as amino and nucleic acids and their precursors. The discovery of 17 complex organic molecules in the protoplanetary disk of V883 Orionis, including ethylene glycol and glycolonitrile, provides a long sought-after puzzle piece in the evolution of these molecules between the stages preceding and following the formation of stars and their surrounding protoplanetary disks. Glycolonitrile is a precursor to the amino acids glycine and alanine, as well as the nucleobase adenine. These findings are pointing a straight line of chemical enrichment and increasing complexity between interstellar clouds of gas and dust and fully evolved planetary systems. The transition from a cold protostar to a young star surrounded by a disk of dust and gas is accompanied by a violent phase of shock gas, intense radiation, and rapid gas ejection. The thing is, it was always thought that these energetic processes would wind up destroying most of the complex chemistry assembled during these early stages. So the study's authors set out a so-called reset scenario in which most of the chemical compounds required to evolve into life would have to be reproduced in circumstellar disks while forming comets, asteroids and planets. One of the study's authors, Camber Schwartz from the Max Planck Institute in Germany, says it now appears the opposite is actually true. The results suggest that these planetary disks are inheriting complex molecules from earlier stages, and the formation of complex molecules can thus continue during the protoplanetary disk stage. In fact, the period between the energetic protostellar phase and the establishment of a protoplanetary disk would on its own be too short for complex organic molecules to form in detectable amounts. It means that the conditions which predefine biological processes must be more widespread rather than simply being restricted to individual planetary systems. Astronomers have already found the simplest organic molecules such as methanol in dense regions of molecular gas and dust clouds which predate the formation of stars. Under favourable conditions, they may even contain complex compounds comprising ethylene glycol, one of the species now discovered in V883 Orionis. Astronomers recently discovered that ethylene glycol could form through the ultraviolet irradiation of ethanolamine, another molecule that was recently discovered in space. The findings support the idea that ethylene glycol could form in these environments, but also in later stages of molecular evolution, in areas where ultraviolet irradiation is dominant. We know that more evolved agents crucial to biology, such as amino acids, sugars and nucleobases that make up both RNA and DNA, are present in asteroids, meteorites and comets within our solar system. The chemical reactions that synthesize these complex organic molecules occur under cold conditions, preferably on icy dust grains that later accrete to form larger objects. Hidden in those mixtures of rock, ice and dust, they usually remain undetected. So accessing those molecules is really only possible either by grabbing the object and digging them out with space probes, or through external heating, which evaporates the ice. Now, in our solar system, the sun heats comets, resulting in impressive tails of gas and dust, as well as comas, essentially gaseous envelopes that surround the cometary nuclei. And through this method, astronomers use spectroscopy to pick up the emissions of freed molecules. And these spectral fingerprints are helping astronomers to identify molecules previously buried in ice. And when you think about it, it was really a similar heating process which is occurring on V883 Orionis. The central star in the system is still growing by accumulating gas from the surrounding disk until it eventually gathers enough mass to reach sufficiently high core temperatures and pressures to ignite nuclear fusion. During these growth periods, the infalling gas heats up and produces intense outbursts of radiation. Schwartz says these outbursts are strong enough to heat the surrounding disk, in the process releasing complex molecules including ethylene glycol and glycolonitrile, and radiate at radio frequencies which ALMA can then detect. This is SpaceTime. Still to come, Boeing's trouble-plagued Starliner spacecraft delayed until at least next year. And later in the science report, the biggest lightning flash ever recorded on planet Earth. All that and more still to come on SpaceTime. NASA says Boeing's trouble-plagued Starliner spacecraft may be delayed until at least next year and won't be carrying humans when it does finally return to the skies. The announcement came as SpaceX was preparing to launch its 19th manned Dragon capsule, carrying Crew 11 astronauts to the International Space Station on a Falcon 9 rocket from Launch Pad 39A at the Kennedy Space Center in Florida. SpaceX and Boeing were supposed to share the duties transporting crews to and from the space station as part of NASA's Commercial Crew program. SpaceX began flying astronauts aboard Dragon in 2020, but the ongoing plague of problems with Starliner means that it's really not ready to carry people again until the second crew rotation slot, which won't be until near the end of 2026. See, there have been a string of technical issues over several years with Starliner. And even when continuing problems with the unmanned test flights were finally sorted out, well, sort of, and Starliner was cleared for an 8-day manned mission to the space station last June, there were helium leaks in the spacecraft. There were also thruster control problems with the propulsion system during the ascent to the space station. And these all combined to force NASA to scrub the use of Starliner for the return to Earth. And that stranded its crew on station for over 9 months. That was until they could finally hitch a ride back to Earth aboard a Dragon capsule. As for the Starliner spacecraft, well, it turns out it did return to Earth safely, landing at the White Sands Missile Range in New Mexico in September, but without the crew. Boeing and NASA took a close look at the latest problems with Starliner. They've elected to find a new sealant material to address the helium leaks, and they're looking at several hardware changes in order to try and deal with what's been determined to be overheated thrusters. The hardware will draw heat away from the thrusters, and they'll also install thermal barriers around them, which hopefully will solve the problem. Needless to say, only time will tell. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that you could be breathing in tens of thousands of microplastic particles every day. Microplastics are particles less than 10 micrometers across. That's smaller than a speck of dust and 7 times thinner than the width of a strand of human hair. A report in the journal PLOS One collected air samples from apartments and cars in order to see how common microplastics were in the atmosphere. The authors found that 94% of the particles they detected fell in the microplastic size range, which means they're small enough to be easily inhaled deep into human lungs. Now, when combined with other published data, the authors estimate that the average adult's probably inhaling around 68,000 of these superfine particles every day. Well, we've all seen those horrific images of children just skin and bones that look like they've been starved nearly to death. What the perpetrators of those images didn't tell you is that these children are actually suffering from genetic diseases, including cerebral palsy and cystic fibrosis. But they were deliberately being portrayed as suffering from starvation in order to have a huge influence on public opinion and among journalists and political leaders who had access to the real facts about those images but thought not to mention them. The observations highlight a new study reported in the journal PLOS One, which found that 100 Instagram posts with higher user engagement and higher relevance had different effects to different socio-political movements. The movements they looked at were Black Lives Matter, women's marches, climate change, and anti-war demonstrations. And they found that the images being portrayed by these groups can shape public opinion regardless of the true facts. After first manually categorizing whether each image was positive or negative, the authors then used machine learning to analyze comments about each image as being either positive or negative. They found a strong alignment between the sentiment scores for the image and the sentiment of later comments, especially when they related to anti-war demonstrations, possibly due to the emotionally charged nature of the images and the lack of knowledge about their real origins or context. However, the authors also found that images related to climate change protests showed less correlation, possibly because they relied on users being more informed and therefore better educated about the issue. The findings support the idea that images have a strong influence on public sentiment on socio-political events, regardless of the real facts involved in the case. The World Meteorological Organization says a megaflash stretching 829 kilometres has set a new world record for the longest lightning flash ever recorded. The megaflash occurred back in October 2017 during a major thunderstorm, and it extended from eastern Texas right through to near Kansas City. That's the equivalent of the distance between Sydney and Melbourne. Now, this particular flash wasn't identified in the original 2017 analysis of the storm, but it was only discovered when researchers re-examined the thunderstorm's details. The new record, which was confirmed with the help of satellite technology, is some 61 kilometres greater than the previous record, which also covered parts of the southwestern United States back on April the 29th, 2020. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.